welcome to Azure Serverless Conference.
Welcome to Azure Serverless Conf.
Welcome to Azure Serverless Conf.
My favorite part about serverless technology is that it's so easy to get started.
My favorite part of serverless technologies is the ability to be productive without having to worry about all the underlying bits and pieces.
My favorite part about serverless technology is that I can get started super quickly and I only pay for what I use.
Just let me write my code, build my integrations, spin up databases, and Azure, you take care of the rest.
My favorite thing about serverless technologies is no infrastructure maintenance.
You don't have to think about compute or storage. You just get started and start building your apps.
I am looking forward to connecting and engaging with our community and all of the viewers that join us today.
I'm looking forward to hearing from people all around the globe about what they're doing with serverless and seeing what I can learn and make my applications even better.
Over the next 20 hours, we will have some fantastic live sessions showcasing many of the serverless technologies available in Azure, as well as a host of sessions you can watch on demand.
Enjoy the event.
Enjoy the event.
Enjoy Azure Serverless Conf.
Hello, everyone. My name is Mary Lagdimatulak.
And I am Barbara Forbes.
And we are your hosts for today.
Welcome to this very first Azure Serverless Conf. While we get started, why don't you share in the screen in the chat where you are streaming from?
So Azure Serverless Conf is organized to provide a stage for the Azure developer community so that they can share their knowledge in building applications and services using Azure serverless offerings such as Azure Function, Cosmos DB, SQL Serverless, and Logic Apps. So for over the next 20 hours, I guess this is the last leg of this conference, but you will still see and hear from our community members around the globe who have built amazing applications and services using serverless technologies.
Yes, we have had three-hour live streams, and this is the final one. So 2 have happened already, and this is the final live stream. Next to all the live streams, we have a full track of on-demand sessions, which are all available at aka.ms/Azure Serverless Conf. But now, first, we're going to have a live stream with some great content coming up. If you're going to miss any of the sessions, I don't think you should because you're here already, but if you're going to miss any of them, don't worry because they will all be available on demand after the stream concludes. There will be a Q&A with the speakers for every session, so if you do have any questions, don't hesitate to put them in the chat. And for this introduction, we do want to mention the Code of Conduct. On Learn TV, we are committed to treating each other and the planet with respect. Please reference our Code of Conduct on the event page by visiting aka.ms/Azure Serverless Conf. And yeah,
right, let's get started.
Yeah, let's introduce our very first speaker of this live stream, which is Eldert. Welcome, Eldert.
So thank you, and thank you for having me here today.
So Eldert, I know you are from the Netherlands. Are you streaming from the Netherlands today?
Actually, I'm not. I'm currently in London. So this is my fifth week in a trip around the world, basically. So I've been in Romania, US, Poland, and now UK. And mostly because of we are doing in-person conferences again next to these virtual conferences.
And you are enjoying every minute of them.
Definitely.
All right, well, we can't wait for your session on the Azure Integration Platform building serverless applications. So take it away.
Thank you. So first of all, everyone, thank you for being here. It's amazing that we can do these events, like 24 hours basically or something like that, like 3 different time zones and just a lot of amazing content. So welcome to Azure Serverless Conf and welcome to my session. So I'm going to talk today about Azure's integration platform and how we can build serverless applications with these services. So a little bit about myself, very quickly. I'm Eldert Groteboer. Like was already mentioned, I come from the Netherlands. However, I'm currently in the UK, but in the Netherlands, I work for a company called Motion 10. We focus on everything Microsoft. So myself, I focus on Azure and integration. I'm also an Azure MVP, so I love working with the community, which is of course why I'm here today. So I love speaking, blogging, writing. And if you have any questions or any remarks, you can always contact me on Twitter. So just send me a message over there and I will always contact you back. And with that, let's actually start the session about Azure integration services. Now, Azure integration services is a suite of different services within Azure. And I'll show you which service in just a second. But they help you to solve your integration issues or your integration scenarios. And these integration scenarios, like I said, I work with Azure and integration a lot myself, so I've seen very many different scenarios. But let's have a look at the different kind of scenarios we can basically distinguish. So first of all, we have application to application. So we all know that we have a lot of applications normally in our landscape. We have ERPs, we have different kind of applications that we want to connect together, like our ERPs, our CRMs, our invoice systems, HR systems, you name it. Like there might be 20, 30, 100, 500, how many applications you have. And also they need to exchange data in some way. And you don't want to just say, okay, I'm just going to connect everything to each other, because then you have a big spider web of all different kind of connections and won't be handleable anymore. So that's where integration comes in. So integration platform helps solve this. We also often see this in a business-to-business scenario. So we might have some customers, some partners, some vendors, and we need to exchange data with them. So once again, these are different systems communicating to each other, and we want to exchange the data and make sure that we actually do this in a secure way, in a way that is handleable. Like we want to be able to monitor this. We don't want to have the spaghetti connections with connection to everyone. We want to have something in the middle within our integration platform to actually handle this for us. Also, of course, we see a lot of SaaS applications that we are going to connect to. These days, more and more applications you can actually just get off the shelf, like Salesforce, Dynamics, you name it. And we want to actually connect these as well to our own applications. And so once again, this is where those integration platforms come in, to make sure we can easily connect these and also get the data from there and to there as well. And finally, IoT. And IoT is a really big scenario that's been coming more and more, because IoT is basically just a lot of data that gets exchanged. So we want to make sure that once again, we can get this data in and we can integrate it into our processes into our scenarios and use the data to make our solutions better. So these are the integration scenarios. But we do face some challenges when creating these scenarios. So after we are working with many different interfaces, different APIs, they might be hosted on different platforms, they might have different connection methods, different types of authentication, all those kind of challenges that we might face. We have to make sure that we can actually overcome these challenges. And also we often will see that data sources use different formats. Of course, when you are using dynamic CRM, it will have a completely different format than, for example, Salesforce. But you will still want to exchange data between these. They both might, for example, have a customer in there, but this customer in Salesforce looks completely different than the customer in Dynamics. So we need something in between that's going to map that data for us, transform the data, maybe even transform like the whole from SOAP to REST, maybe transform from CSV to SQL, you name it. We have many different data sources, different formats. We need to all connect together. And once again, this is where that integration platform comes in. And we want to work in a service-oriented and distributed way. We want to make sure we can scale. We want to make sure that we actually use services. We don't want to directly go into SQL. Instead, we place the service in front of it and expose that service. And that way we have a nice way to connect to this and actually have a nice way to share this maybe with our partners or something like that. And of course, many of us will be in the cloud already, but there will probably still be something on premises. So we still have to make sure that you can actually connect to those on-premise systems, can get that data as well. And all, of course, in a secure way, but also in an easy way, because we don't want to fiddle around with many different devices and settings. So this should be easy and scalable, all once again, to set up. And this is where the Azure Integration Services come in. And Azure Integration Services is not like a package that you get, it's just different services. You can use them on their own, you can use them with other services, but they're basically a package of services that Microsoft has said, okay, these are the 6 different services that you will mostly use when working with integration. These are not the only services, you don't always have to use all of them. And like I said, it's not like if you buy one, you get all of them. It's still like different services, just as Azure. So you can just use them when you want, you can use them the way you want. But these are basically like a nice package, like, okay, these 6 together will probably help you on most of your integration scenarios. So first of all, we have Logic Apps. And Logic Apps is a low-code environment. It's a lot of drag and drop configuration, so very easy. And allows you to orchestrate your process, saying, okay, I first want to do this, then this, if this, then that, go out to different services. And there's a lot of out-of-the-box connectors. So I can connect to 450 different systems out of the box. So it's just very easy to get used with, to get started with, and allows for that easy configuration of your workflow. Next, we have functions. And most of our processes will have some custom logic. I might need to calculate a specific hash on something. I need to calculate my pricing. I need to validate something. These are things that you can easily implement with code, host some functions, and then it will just execute whenever needed. And once this is of course one of those serverless applications, so you only pay for what you use. It's highly scalable, so very nice. Data Factory allows us to do ETL operations. So extract, load, transform. And this is more about batch processes. So Logic Apps, functions are more about event-driven. So something happened and I want to do something. Where Data Factory might be, okay, I have a database over here, I have a database over here. And once per night, I want to actually load the data from this database, maybe do some transformation, put it into this database, and just like full loads or at least batch-driven processes. Now for enterprise messaging, we have Service Bus. And Service Bus is really about messages, as the name says, as the tier says here. The messages are, hey, I want you to do something for me. For example, I want you to create an invoice for me. So I'm telling one system is telling another system, please do something for me. And of course, this is enterprise messaging. So this we have to make sure we process in the right order. We process all of the messages. We want to know when something goes wrong. So it's really about those valuable messages that we want to place into a service bus, and then we can place it into a queue or a topic. And the queue is just I place some messages in, and the receiver will get it out. A topic is I place a message in, and one or multiple receivers can get it out, depending on filters. And this allows me to have that queue in the middle that will decouple our systems in a secure and enterprise-ready way. Next up, we have Event Grid. And this is for events. So unlike messages, events are more about, hey, something happened and someone might be interested in this. I don't know who's interested. I don't know what you're going to do with this, but you might be interested. So I'm just going to put this out to Event Grid. And then the different subscribers have subscription on Event Grid, and Event Grid pushes it to all these different subscribers. And finally, we have API management. And API management allows us to expose our APIs in a secure way, in a controllable way. There's one endpoint for all our different partners. So all our APIs are exposed to API management. So there's one single entry point. We have one way of authentication, one way of authorization. While having many different background services that might have many different locations where they're being hosted. They might be on premises, they might be in Azure, they might be in another cloud. They might be different technologies. I might be exposing functions, APIs. I might be exposing logic apps. I might be exposing a web app. I might be exposing an old SOAP service. The consumer doesn't really care about this. They just connect to API management with their own ways. And in API management, we as the publishers can create policies, for example, for throttling, for caching, to make those APIs a bit smarter and basically decouple the backend from the front end. And of course, when we are working with Azure, it's always better together. We have seen that we have these 6 services that we can already use together. But of course, you can also introduce a lot of other services. And of course, today we are talking about serverless services. So that's also, I will be showing a demo in just a moment where we will be using all serverless services to build our solution. But there's, of course, many more out there. Think about Cosmos, an amazing document store. Think about SQL. Think about all these different serverless services that we can just use for our solutions. So definitely, whenever you are looking at a scenario, make sure you understand what services that you need, and then look, okay, what are the best services out there? Because it introduces limited possibilities. But now let's actually go to a demo. And this demo is going to use, like I said, all different serverless services to create an integration scenario. And this is an onboarding process. This is based on an actual process that we implement with the customer. And the customer basically came to us saying, hey, we currently, when we onboard a new colleague, they have to fill out many different forms, it goes to different people to actually sign these forms. It gets like scanned in, emailed around. There's just a lot of hassle going on. And often these forms go missing and they need to be done again, or someone forgot to put something on the form, or it was filled in incorrectly. It just meant there was a lot of time spent on things that you actually didn't want to spend this on. So when we came in, we said, okay, let's have a look what you already have, and let's have a look how we can build a nice process around this. And for like I said, they want to have serverless because serverless allows them to once per month actually scale up very highly because they might have many new colleagues. And then once again, once those colleagues are there, they will scale down again. The rest of the month, there might be a few operations, but they are not paying anything basically. And once the next months come in, they can scale up again. And once that is done, scale down again. So they only pay for what they're using, but they also know when they have a high load coming in, they can actually process this because all these serverless services will just scale up with them. So first of all, we saw that they already had SharePoint. So we're like, okay, SharePoint will be our place to actually store our data. I'm not saying this is the best place, I'm not saying this is the only place, but in this case, it made sense. They already had it. For them, it was easy to actually edit the data when needed. It was a nice interface for them. So we're like, okay, let's do this. However, they did want not to just work on SharePoint directly. We said they actually wanted to introduce Power Platform. So the Power Platform allows them to go onto their mobile devices, on their laptops, on the web, and have a nice interface to actually fill out the data without having to go to SharePoint itself. So once the data is in SharePoint, then our process actually starts. And in this case, you have a logic app, and this, of course, is one of those serverless services. So the logic app gets triggered by, hey, a new item has been created in SharePoint, and I'm going to start my process. And the first thing we are going to do is actually check, send out the email to our manager. So we'll check, okay, who's the manager, who has to assign for this. And then the manager will actually say, okay, this is actually the right data. It will approve, or of course, if they say, hey, this is not incorrect, then they can reject that data. Now, when it's rejected, another email will be sent. When it's approved, it will actually start the rest of the process. And in this case, we are going to write back to SharePoint, saying, okay, it's approved. And then we are going to do some calls. Because of course, in any company, You might want to have, for example, a telephone. You might want to have a laptop. You might get some licenses. And for them, they use some different systems for this. So first of all, they have Top Desk, and Top Desk allows them to say, okay, I need a laptop, I need a telephone, things like that. So we're going to call out to Top Desk, and they will do this via API management. And then Top Desk will come back, and actually I'm not calling out to Top Desk itself, I'm just using mocking for a service for this. But in real life, they actually called out Top Desk, created a ticket, and then that process started of actually acquiring that hardware. Also, the system, the data needs to be HR Today because that's their HR application. This makes sure people actually get money at the end of the month, so quite important. So we're also going to call out to HR Today, but that's what we actually do via Customer Connector with Logic Apps. So this is one of the other options that they actually have. Once this is done, we are going to create a contract. The contract is going to be pushed onto a service bus because it has to be encrypted. And then we have a function that gets triggered off the service bus. So whenever a new contract comes on there, a function will spin up, it will actually encrypt the data, and then it will be placed into a storage account. Now on the storage account, we can have a nice trigger with event grid. This is all out of the box, so very nicely integrated. And the event grid will actually say, okay, I have a new message. I will get this message, put it into the same queue, but in the same source bus, but on a different queue. And then Logic App will actually come back, see that the message is there, and then we'll actually send out an email to our new colleague saying, hey, here's your contract, and welcome to the company. So let's go to my demo. So start over here. 1 second. Do it like this. And my demo is gone. Okay, so actually my Power App is gone. So instead of starting this up, because that might take a bit, I'm actually just going to go directly to SharePoint. So actually I started before my session, but apparently for some reason it's gone again. But no worries, like I said, Power Apps is just a front end for my SharePoint site. So instead of using the Power App, I'm just going to go over here and let's see. 1 second. So I'm not sure what's happening. Let me just refresh here. Of course, demos, like I ran this demo before my session. I went through everything was working. And of course, now it's like, hey, let's do some. Okay, so once again, let's try this. Should be okay. There we go. And there we go. Empty name. So I will be the one that's going to start. Gotta love live demos, right? Everything that can go wrong will go wrong. So let's say we are starting next month in a few weeks. So let's go over here on a Monday. Okay. Here we go. My function, I'm going to be a technology lead. I'm just going back to my old current role. And I might want to have some materials. Where's my drop down? Quickly, what is happening? So let's first save this. In the meantime, I'm actually just say, okay, let's also start this onboarding one. While this is opening up, it will give an error message. So that's why I'm saying like it takes a bit to actually start this. So I think it's maybe if I do something like this. It's not showing. There should be 3 options in here. So anyways, let's see, because it will already start my session, my demo, and I can just show you what will happen. Or it should have been. Did I forget to save it? I thought I saved it, but okay, I will try once more. If this is not working, unfortunately, I still have from yesterday some data. Let me try it over here once more. So let's refresh this data. In the meanwhile, I will actually, there we go. So one more quick try, and otherwise I will just show you the data from yesterday. Like I said, it's always nice doing live demos because you know that everything will go wrong. So while this is loading, let me just show you in between over here the Logic App that's going to start this. So like I said, I have Logic App, and the Logic App is actually going to start whenever I do it in my SharePoint environment, and it will be triggered by, hey, a new item is created. Okay, this is also shown. Sorry about this. Like I said, before my session, I actually ran through all of this. Everyone was working nicely, but as we all know, there we go. So whenever an item is created in SharePoint, and this will be in that list that I just showed you, this will trigger. And as you can already see, this is all basically just configuration. Like I don't really need to code anything. And if I want to add a new item, a new action in here, I have a big list of different options. So I can do this all and then just drop this down. And what you will see, there's a lot of different services out there. Of course, there's Azure services out there, Microsoft services, but also like Adobe, there's Google in there, Amazon, like there's different services. So it's not just Azure. There's many different services that you can use here. And as you can see, I can just use these connectors. I could select one of them, and then I can just configure this to say, okay, what do you want to do? So like I said, I will send an approval email. I will check if it comes back as approved or not. So if it's approved, I will just go on. I will update the item. If it's rejected, I will stop the flow and I will set it to rejected. It's going to call out to my API management. And here it will send some data to top desk. It will call out to my HR today, and as you already can see, this is actually a custom connector. So I actually created this myself. I'm going to create HTML to PDF. I'm going to create an HTML file page, convert it to PDF, and this is one of those third-party connectors. So Muhimbi, and I can just place that contract in there, and then I'm going to send it out to my service bus, and then I'm going to wait for it to come back, parse the JSON, get the message, and finally send an email. Let's try. There we go. There it is. So let's try once more. To say, okay, this is me. My starting dates, once again, let's do next month. Function, tech lead. And as you can see, these were the options that were not loading. And then my email address, let's put this one. So there we go. So this is going to start this process. And then we are going to go over here. Over here, actually. This one, there we go. So this is going to start at Logic App. If I refresh this, it should be running. There we go. So it's running. It goes through these different steps. So, and if we open this, we can actually wire this at the moment. I'm going to get an email. So let me open up my email account. So it's now actually sent out the approve email and saying, okay, I want to have a response for this. And 1 second, it should be there. Just a second. There we go. Let me actually put this on the screen for you so you can also see it. There we go. So this message just came in. As you can see, 1027. I can now approve this. It will come back to my Logic App. So in my Logic App, I should see that it's going to the next steps. It's approved, so it actually goes into the true site and will actually say, okay, so then I can continue. And it should continue just in a second. Let me refresh actually. Yeah, there we go. So it's now going through. As you can see, got the update. It's going out to HP. So it's going out to my API management over here. In API management, I have this operation for top desk. Now, like I said, I'm just using a mocking service over here. Of course, in real life, this would actually be my top desk API that I'm exposing here. So once it's in top desk, it will also go to my create employee operation over here. Now this is actually a custom action. So like I said, in API in Logic App, you have actions 450 plus out of the box, but you can also create your own. And basically what you do, you just load a Swagger file or a SOAP file. It will get all the operations from there. It will create, it will read the operations. You can edit, of course, like you say, I want to use specific operations. I want to have this data in here. And it will then call out to this. Then it went out to the Muhimbi, which is going to actually go out, create a PDF with our contract. It's going to send a message to my service bus. And this will then be triggered by my API, by my function. And in this function, like I said, the function is awesome if you want to create some custom code. In this case, we are just going to encrypt my contract with PGP. So I'm having PGP in here. I'm going to encrypt my entire stream. So I'm getting a stream of data. And then in the end, it will give back that data to my, it will store this data onto a storage account. So if you go over here to my storage account, I should be seeing, let's see, where's distance? That's my service bus. My function that's of course running, and then this should be my storage account. There we go. So I have these contracts over here. I should see here now a new contract. over here. So that has just been created. And what happens then? So with, if I go back over here, I actually have these events. With these events, I can configure saying, okay, whenever a new file is created, trigger an event grid subscription. So I can then say, okay, this event grid should start a logic app, and actually function something else. In this case, I have created one here already, and it's calling out to a webhook. Actually, not this one. This one. So I have my event grid topic over here. I have a subscription on this for service bus. So what this does, whenever something is created on my storage account, it will push this out into the service bus. And then the service bus can actually start, let's go logic app, continue. Let's see, there we go. Oh, something went wrong. So I will actually just show you the one from yesterday. And because I'm not going to debug it now, probably something in my JSON that was incorrect. I'm not quite sure why. I will show you from yesterday what will actually happen. So let's go. So it will get the JSON. So the JSON will contain, so it gets matches with the JSON in there. This actually contains that event saying, okay, we have a new blob, and that blob is stored in here. So it's that contract. As you can see, this one from yesterday. Of course, the one for today would actually have the right one from today. It will then get that content. So it's actually going to get a path from there. So it can see, okay, this is actually the content. It's going to get that, this was content from yesterday, like it's just a PGP encrypted message. And it's then going to send this out in an email. And let me quickly check if I can see the email, if I can find the email from yesterday. Otherwise, I'm just going to continue with my extension because I only have a few more, a little bit longer than I need. So let me quickly see, there we go. So this is the one from yesterday, as I said. So let me push this over to here. And let me push to the other screen. There we go. So in this case, my new employee would actually get the contract. As you can see, it has been encrypted by PGP. And if I open this up, I will actually that this is a PGP encrypted contract. And I can now decrypt it myself. So I would have a PGP key, of course, for this. And then I can decrypt it and will actually get my contract with all the data in there. Now, with that, like I said, the demo had a few hiccups, but I think I could show you actually the power of all the different services working together. So we have Logic Apps with a nice visual editor where you can actually create a workflow. We can call out to different systems by using out-of-the-box connectors, custom connectors, just calling out directly to APIs. Then we have API management, which is a nice front end where we can say, okay, for my top desk application, for example, I only want to expose one operation. I could create composite operations. I could introduce things like throttling to say, okay, you can only call this operation for 10 times per minute or something like that. So API management is really that facade over our APIs. We have our service bus to decouple our different operations. So we can actually say, okay, I want to decouple this. I want to make sure that it is stored somewhere safely. Then we have our functions, which can execute custom code. Of course, you have storage. Storage is always important. We have our event grid, which actually triggers on different events. In this case, like out of the box, whenever a blob is created, call out to this endpoint. And all this together is what makes it so powerful. So with that, we're almost done. So let me go to my next slide. Where's my mouse? Over there. So we're almost done. So quick takeaways, and then we go to wrap up. So serverless allows you to really focus on value because you don't have to think about your infrastructure. You just create the solutions and just focus on what brings you value. It's very cost efficient. Like I said, this process that I just showed you, it costs the actual customer, it costs about €1 per month because it only triggers when it's actually being used. And as long as there's nothing coming in, they don't actually pay anything. So for 29 days out of the month, it basically doesn't do anything, so you don't pay anything. And then 1 or 2 days where actually all these contracts are processed, then it will actually say, okay, now everything is coming through. And finally, combine those different services to create more powerful scenarios. Like you could have introduced Cosmos DB here, for example, to store some data. You could have used SQL here. You could have introduced many different services, or of course other services as well. It doesn't all have to be serverless. Like it works very well together also with PaaS services and those kind of services. So really make sure that you combine the different services for your scenarios. So with that, I would like to say thank you. I hope you enjoyed the session. 1 second, sorry. So I hope you enjoyed the session. Thank you for letting me be here. And I just want to make sure that I actually can see my moderators in just a second. If you have any more questions, please shoot me an email, shoot me a message on Twitter, contact me on LinkedIn, and enjoy the rest of this conference.
All right, very cool, Eldert. Great story. Thank you. We do have some questions. One of the questions that came up is how long will the Logic app wait for a response before it will time out?
So this actually something that you can configure. So this can, I don't know, it depends also on the action. Like I think for the Outlook one, it's like up to 30 days or maybe even longer. But the Logic app will just continue waiting and it will can run for, well, not indefinitely, there is the limit, but it's like half a year or something like that. And of course, by then, like if you don't have an approval within 180 days or 30 days or whatever, like by then you might actually want to escalate this instead.
Yeah, that's a pretty long time. That gives a lot of options. And just one more from me personally. Have you already played around with the Visual Studio Code extension for Logic apps?
Yes,
how do
I
you
definitely
feel
did.
about that?
That's, I love Visual Studio Code, especially when you're working at like all the different servers have their extensions. And the Logic app extension is actually quite nice. So it allows you to actually create your app in Visual Studio Code. It allows you to debug them, it allows you to run them. And I'm really happy they made this change because now much easier to actually create those Logic apps and actually make sure they work as you expect them to.
Okay, awesome. Well, thank you for those answers and thank you for a great session.
Yes, thank you, Eldert. And I just want to mention that Eldert has a lot of fans. So I can see from the comment section that there are a few that says, "Oh, Eldert is my idol." So that's pretty cool. All right, so I guess let's move on to our next speaker for today, Bjorn Peters. Yeah, he will be talking about Azure SQL database up and down on your demand. So take it away, Bjorn.
Yeah, thank you. Hi all together. Thank you for hosting me or for having me here. I will talk to you about Azure SQL Database Serverless, or what is in the Azure SQL Database environment for you, and what is the most thing on or the most best benefits on using serverless option. So let me start a little bit about me. I'm Björn Peters. I'm living here in Germany, northern Germany, near to Hamburg. I'm a senior consultant at the Kramer & Crew, you can say. I'm organizing the Azure Meetup here in Hamburg with monthly meeting. I'm doing volunteering, speaking, and to all those community activities here in Germany or Europe international due to the pandemic. I was awarded several times now for 5 years as an MVP for data platform. And in my free time, I father, husband, snowboarder, and so on. And you can read my blog posts, write me an email, or send me some direct mails, or follow me on the social media. So let me start with Azure SQL Database in general, and then I will go into the deep dive of what's around serverless and what you get for your money. So what do you need first? So every time you start with your application or what you want to do with storing data, you want to have a database, in this case, a SQL Server database. So you just want a database for your application. But if you deploy this one in Azure SQL, you will not just get a database, or you have to know about this, that you're not just get a database, but you also get a SQL Server on it. So you have to deploy a SQL Server before, and then you can attach your database or deploy your database in that server. That SQL Server is not really a SQL Server, as you know from on-prem, but it is some kind of DNS name, a listener, where you can connect to and which points to your database. So the SQL Server, or the listener in this case, is your connection string or your connecting item. For example, you have a SQL Server serverless demo, for example, and your database might be named, as you can see in my demo later on. It might be Stack Overflow 2013. So starting with Azure SQL, what do you get if you want to, or if you are deploying a SQL Server or SQL Server database in Azure as a service? So most important thing is availability. What do you need to, or if you deploy your application and your databases within the cloud, you do this and you need, for example, a lot of availability, and how high is this, what is in that price I'm paying for this. So Microsoft guarantees you an uptime of 99.99%, which is already included in the deployed service or in your database. Also included is already a big backup and restore feature. You don't have to care about how to back up or when to back up your databases. Microsoft takes care of everything around backup and restore and provides you all the features and functionalities I will show you in the portal later. So this is already also included within that low price or in that serverless feature. One of the most important things around data is security. You are not just, it's not all around roles, permissions, who is able to do what in your database or might be able to connect to your database, but all around the network security. What is in there for advanced threat protection, virus defender, Microsoft Defender for databases in this case, or for SQL Server. Everything around this, as you can see here, the policemen are protecting something. In this case, they are protecting your data, your databases. This is already built in. Yeah, you deploy a Azure SQL Server or Azure SQL Server database, serverless or pre-provisioned, then this is already built in. So you don't have to care about, or you have to care about by defining a security matrix for your users, for your services, and give them their roles and permissions, but all around the network security, monitoring, and so on is already built in, so you don't have to deploy additional services for this. And even one of those great features are also available in Azure SQL is the tuning feature. You can configure it by yourself, or you can use it in whatever way you want to use it. There is already implemented a feature called tuning or automatic tuning. It's based more on the data which are providing by the usage of your application. So if you have some indexes, or you should implement some indexes on your tables to get a better performance of your statements. And there are some services or features around Azure SQL databases which are looking into the dynamic views of a SQL Server and might recommend them to create additional indexes to get a better performance for your statements, or even drop an index if it's unused. Yeah. So tuning is also an automatic feature here. You can configure it that like this, that they, if there's a recommendation for a new index to be created or to drop an index, then you configure it in a way that Azure deploys that index automatically to your database and send you a message, hi, I have automatically deployed a new index for you. If that index doesn't fit your statements because of some more relevant data is provided, so new index statistics or something, you change your statements, then it might be that Azure automatically drops that index because they don't think it will really help your statements. And the most important thing about serverless and what you are able to configure within Azure SQL Serverless, then we are talking about one of the most important things here for the most of you might be fees. How much do you have to pay for your Azure SQL database? In this case, if you use Azure SQL databases as a pre-provisioned database, then you have to pay your monthly fee. Depending on the storage or how much data you are putting in there and how many CPUs or how many compute power you have added to that database. For the serverless option, I will show you this in a moment in the portal, there is the option to auto-scale and to pause and resume your database. So with the serverless option or serverless deployment option, you can keep your fees low as possible, or as low as you need them, or whatever you choose for. Yeah. So I'm talking a lot about the Azure Portal and what is in there. Let me show you this. It's all about Azure SQL Database, pausing and scaling, and how you have to use, or if you want to use that on your demand, or if you will go down and up if you need them. So let me show you. Let me switch to the Azure Portal. I've prepared some workload here. So as you can see here, in my resource group, Azure Serverless, I already provisioned a serverless demo server that is the SQL server. So as you can see here, it is named also SQL Server, but it is just a DNS name, a listener to your database. So under that serverless SQL Server, I had already deployed some databases, which you can see here. So this is the normal Azure Portal, where you can see the resource group, the availability, where it is deployed, the subscription under which I deployed that one. And here you can see, for example, my server name. That is the DNS name, which I'm using for the SQL Server Management Studio or for Azure Data Studio to connect to that application, or using for the connection string in my application. And one of the most important things, if, for example, I'm here in my demo, and that is one of those security features around Azure SQL databases, it is already included a small firewall, like network security group and so on. Actually, I'm connecting from my local PC via SQL Server Management Studio to that database, and I have to open up that client IP that is provisioned here, provided here, and I can just click on the Add Client IP, which then connects to my, that opens up the port in the firewall that I'm able to connect to the database. So in the overview of my SQL Server here, you can see also that I have that provided databases here, Azure SQL Serverless and the already known Stack Overflow 2013. And you can see here the paused status, and it is deployed in a general purpose serverless Gen 5 with 4 vCores. And I can show you how to configure this later on, or I will show you this in a minute. So actually, I clicked on the configuration or the item Stack Overflow 2013, which is the database. Here we also can see the server name as a connection string, and Microsoft provides us here also the opportunity to directly pick up a connection string for ADO.NET, JDBC, ODBC, PHP, and Go. So you just have to copy that connection string, paste it into your application, and the application will be able to connect to that database. That is one of the great features here, which is helping you a lot. Then we can see here we have the pricing tier, and we have here some kind of monitoring. Yeah, data, it's red here. I have provided 32 gigabit of storage, but I'm just up to the I'm short of storage, so the Stack Overflow is a little bit too high for it, or too big for that. If I change the metrics here, you can see a small window. I can click on that, and then I will show you what is happening here. So I have some workload provided for that database, and you can see here during the last 24 hours, there was some time where it's up and running, or my application is connecting to that database, and we have some times of idle time here, earliest from this night to right now. This is also why the status of the database is actually paused. So in the serverless, Azure SQL Serverless deployment, I am able to set a timeout, after which is ended, they shut down my database and I don't have to pay any more for that compute power. So that is one of the big benefits of serverless. And I will show you how to configure this. So I will show you later, if I'm executing my statements again, it will start up the database. The first connection the first connection will take a little bit longer than expected, or than it is on the second try or the third try, but that's because they have to redeploy or reattach your database to the compute power. So if I'm going back to my database, then we have here the pricing tier, which is actually general purpose. So, and here you can see it's actually deployed in the service tier general purpose and in the serverless option, the pre-provisioned or the serverless option. And due to the serverless option, I'm able to configure my compute power here. I can change it if there are more than one generation of hardware, underlying hardware. Then we might change from Gen 5 to Gen 6, for example, or earlier from Gen 4 to Gen 5 right now. You can see here we can actually deploy up to 40 vCores, which have a ratio on your memory. So if you deploy 40 vCores, you will get up to 120 gigabits of memory. If I want to change this, you can see here that is actually the only option how to use this, Gen 5. So here we have two sliders which are able to, or where I'm able to configure my max vCores and min vCores. So depending on your workload, as you might have seen or remember my metric, you can see that I have provided actually 4 vCores, max 4 vCores. So my workload is a little bit too high and I have reached that 100% opportunity to gain or how to use all my vCores, and my CPUs are running at 100%. So that is a tip, a hint to increase my max vCores, for example, up to 6 or up to 8 vCores, which I can do here by providing the slider or moving the slider to the right. And then I can choose also the min vCore, and depending on my workload, for example, if it is going down to idle, it will decrease the compute power to at least 1.5 vCores, but it will increase, if necessary, to up to 12 vCores. So if your workload, like mine, for example, will always use up to 100%, your database will scale up to 12 vCores, and then you have to pay for that time. If you're using those 12 vCores, you have to pay the whole time for that 12 vCores. But if it's going down to the idle, it will also decrease your vCores down to 1.5 vCores, and then you just have to pay for that idle time for those 1.5 vCores. That's how you can reduce your costs or your fees on your database. And here we have the other option, auto pause delay. We can enable auto pause, which means here in this case, in this configuration, if your idle time for your database, there is no more connection to your database, and if that no more connection is running out of time after 1 hour, so it will shut down your database. You can't decrease it even more down to, for at least, for example, down to 30 minutes. The minimum downtime here or idle time is 1 hour, 60 minutes, but you can increase it, for example, to 1.5 hours. So yeah, and you can also get more storage for this. Yeah, and if I'm going down to the back to the recommendations here attached to my SQL Server, you can also see, for example, here we have Azure Defender, which is the inbuilt security feature. For example, you can put the Azure Defender onto your SQL Server, which then scans and manages the security of your SQL Server. And we have a recommendation to create another additional index, which I already showed you in my slides. So here you can see, for example, what is Azure actually recommending for that database to add a new index, like with this name as a non-clustered index on this DBO schema table comments. It should include the user ID. It should run on the user ID and should include another column named score. So we can also see here, for example, the view script. So I don't have to care or don't have to think about how to include this or how to create that non-clustered index. It is already provided here. And I also can auto deploy this with the apply button to the database. Actually, I don't have that storage. You can see here I have it will increase my data storage up to or with additional 8 gigabits. So as you have seen, I'm already running out of storage with 32 gigabytes. So I also have to increase the storage underlying there. So yeah, and then I will switch to my SQL Server Management Studio just to show you. I have that connection here. You can see I just use connect through that database. I'm putting in there my DNS name, username, password, press the connect button, and I'm coming down to this view here. And you can see here, for example, this server is actually running 12.0.20. So this is not corresponding to the SQL Server on-premise version numbers. That is Azure SQL Server. It is a little bit different to that, and you can run, for example, the version statement here, where you can get more information about this. As you can see, it's 12.0 from July 21, and here you have Microsoft SQL Azure RTM. That's the actual running version of that SQL Server. Yeah, and if I actually start here my my workload, for example, I'm just pressing enter. There is actually no, sorry, I just changed. I have to change the, it's not running, it should not run in the master. That's why I'm getting this error messages. I have to change it to the Stack Overflow database. And now you can see it's taking a little bit more time as we might used to. It is starting up my database. That is the first connection try, and it will take some seconds longer. Starting up my database, attaching it back to a SQL Server. That's like the detach attach feature in a normal SQL Server. And we will see here in the that it will start up, or that the status will be changed in a few seconds, or it should be changed in a few seconds. Yeah, here you can see it's online. And then if I switch back to the Server Management Studio, it has changed and I can run my workload again. So without any message, you can see beginning execution loop, and then my workload will be executed. So I'm running out of time. I have just to give you the inclusion of this. I think this is a awesome feature or awesome service, how to deploy that service features with high availability already included, with backups already included, tuning, security, auto pause, auto scale, and that based on a monthly low fee. So you are able to configure how many CPUs, how many workload you have, when to shut your database down. For example, if you have an application which is just used during the night or during the day, then it can be paused during the other hours, non-working hours. So let me say, yeah, it's great. Use it, give it a try, and just pay for your usage, not for the whole month, for example, in this case. Do we have any questions?
Hi, thank you very much, Bjorn. We actually have a couple of questions from the audience. So one of them coming from Fuels Enable. And what is a good way to implement data retention in SQL Server, like delete all rows older than X days? Is there something built in, or do I have a scheduled stored proc?
That should be handled by the application. Yeah, so you have to implement some stored procedures or delete jobs, which are doing archiving or deletion of that data.
Yeah, so basically no time to live. All right, and then we have another one coming from Mike Rees. How long does it take for DB to restart, and what are the ramifications for developers when hitting an inactive serverless database?
As I just showed you, depending on the deployment and how big is your data, as I already said, it's some kind of attach method on your SQL Server. If your database is slow, it might just take 5 seconds or 10 seconds for the first connection. But if it is, for example, a 4 terabyte database, which might take some more time to reattach, then it might be up to 30 seconds, 40 seconds, like something like this.
All right, that's good to know, so that developers can actually handle this transition. All right, thank you very much. Thank you very much for joining us today. And for now, we have some videos for you.
Yeah, we have some content coming up. If you are looking for a great place to keep up on all the latest and greatest in Azure data, check out this video on the Data Exposed show with Anna Hoffman.
Hi, I'm Anna Hoffman from the Azure Data Product Group, here to tell you about a show I host called Data Exposed. We talk about all things data, what's new, deep dives, how-tos, and we even give you a glimpse under the hood from the people who actually build the products. We cover topics like
Azure SQL security,
running high-performance SQL Server workloads on Azure virtual machines,
migrate all your database assets to Azure SQL,
data science with something old and something new,
Azure SQL Managed Instance,
developing apps with Azure SQL Database,
and more. We post short episodes on Thursdays, and once a month on Tuesdays, we release a special MVP edition with the community.
May the 4th be with you.
Catch us live on Learn TV on Wednesdays at 9 a.m. Pacific.
Yeah, that looked great. Like a lot of fun, but yeah, let's now move on to our very next speaker. Ricard O, welcome to the show. How are you?
Hello.
Thank you. I'm great. How are you?
I'm good, and I see you are joining us from Sweden.
That's correct.
You are from Sweden, so I assume you might be joining us from there as well.
Yeah. From the middle of Sweden, a town called Örebro.
Well, great. Yeah. And I see you have a session coming up on Azure troubleshooting with Azure Monitor, and we're very excited about this one. So without further ado, take it away.
Thank you. So welcome to this session. Become an Azure troubleshoot rockstar with Azure Monitor, hopefully. Goals with this presentation is I want to give you an intro of Azure Monitor. I want to showcase Azure Monitor specific to serverless and PaaS services, because Azure Monitor is huge. There's a lot of services that we could cover, but we don't have the time for that. And I also want to motivate you to start using Monitor, to start using Azure Monitor, because I think it's a great tool to use. And since I've worked quite a lot with this service or services, I also want to give you some learnings that I have encountered during the years. A little bit about me. I'm a cloud solution architect in my own company. I've worked with Azure for about 10 years. I really promote sort of PaaS and serverless services. I'm a big fan of monitoring and a big fan of application insights and Azure Monitor and all that. I also organize a .NET user group together with a few friends in Örebro. And I'm also a lover of Azure and also Legos, as you might see behind me here. So why should you even do monitoring? So the old school approach is sort of reactive. It's something goes down and you want to know about it and then you fix it, sort of. But to me, monitoring should be, if you use the right products, it could be much more innovative. You could actually see into the future, sort of analyzing trends about what is happening right now, and in a day or 2 or 2 hours, what will happen then? And then you could be alerted about that and sort of fix the problem beforehand. So you should use monitoring to solve issues before they even appear. And you should also use monitoring in your non-prod or dev or test or QA environments, because then you would probably find issues faster before you even deliver them to production. And of course, from a serverless perspective, you can learn how your app behaves and scales from monitoring, from metrics and logs, and that could lower your costs in Azure. You could also find security breaches and take data-driven decisions, no matter if it's business decisions or technical decisions. But in the end, it's to make your customers happy. I mean, your system should be up, and the SLA of your system should be many nines. So there's a lot of different services in Azure. One question I often get is, what about Azure Security Center and Azure Sentinel and Azure Monitor? And they, in turn, have a lot of sort of services underneath them. So Security Center is a security management system. You can do threat analysis with Azure Defender, which is a part of Azure Security Center. It provides security recommendations of the configuration of your services. For example, you should only allow HTTPS. Then you have a Azure policy that helps you sort of check that on your applications. And it also helps you know that you're compliant to certain certifications and all that. And Sentinel, on the other hand, that's a CM system. It's a well, CM stands for Security Information Event Management System, and that's sort of to detect and analyze security threats. And Azure Monitor, that's more operations monitoring, sort of looking at logs and metrics and sort of getting to know your application. But what all these services have in common is that they have log analytics as a sort of a data store for all their data that they then analyze. So Azure Sentinel and Security Center uses parts of Azure Monitor to function, but these complement each other. But today we're going to talk about Azure Monitor and the services in there. So how does Azure Monitor work? So over here we have different kind of applications or your infrastructure, like virtual machines or networking or whatever. We have your Azure platform, and you can even have custom sources that sort of sends data to either a metrics database or a logs database. This is sort of the data store then that all these resources send data to. And then you use a bunch of tools to analyze, to get insights of this data, to visualize it, to understand it better. You can go super deep and analyze it using the Metrics Explorer or Log Analytics or Azure Monitor Logs. You can respond on this data. You can configure alerts that when this happens, I want to do that. And you can auto-scale depending on this metric data. And you can also send this data to other monitoring platforms if you wanted to. But how does this all work with serverless then? Because that's what we're here to talk about, right? So with serverless, it's sort of the same. Let's say we have an Azure function. It could send its data to application insights, and application insights using logs as its data store. Functions also could also send logs and metrics directly to these. And it's sort of the same for logic apps and Cosmos and storage and SQL. You just set up your diagnostic settings or onboard using an SDK, for example, for application insights, and then it will start sending data to the data stores, and then you use all these tools to get insights and visualize and think about your monitoring data. So if we just jump into an Azure service, for example, Azure Cosmos DB, as you can see here, and you scroll down a little bit, you will see that you have on almost all services, you have a monitoring section in the Azure portal. And here you can provision alerts, look at metrics, logs, set up the diagnostic settings for your logs. And you can also look at workbooks, which we will talk about in a little bit. So that's how you set it up. So I want to jump to the Azure portal and just show you what it looks like if you enter the Azure Monitor blade in the portal. So here I am in the portal and I click Monitor. In the left pane here, I'm presented with all the different monitoring services and settings there is for Azure Monitor. It sort of aggregates all the different services that exists. Here we have the activity log, which it's the audit log for Azure that's saved in Azure Monitor. You can configure alerts, which we'll have a look at later. Metrics are saved usually up to 93 days for free for most resources in Azure automatically. Logs, you have to configure your diagnostic settings to start sending logs there, and you will pay for the ingestion and storage for that. You can also see sort of the resource provider health of different services here. And you can use sort of interactive reports called workbooks, which we will look at in a little bit also. And here we come down to the insights, which are more specific insights for each service in Azure. So here we have application. This is application insights. We will use this one later also. We have storage accounts. And these are sort of specialized workbooks that show you different kind of metrics from this one in a user-friendly way so you can troubleshoot faster. And there's container insights and network insights, SQL insights, Azure Cosmos DB insights. As you can see here, there's a lot of different stuff. And down here on settings, you can actually set up at scale all your monitoring settings. And you can also do this from policy, for example. So that's an overview of Azure Monitor in the portal. I mentioned earlier Azure Monitor workbooks, and this is a pretty huge deal in my opinion. Sort of visualizing monitoring data is a big part of doing great monitoring, because you need to understand the data. If the data just lies in a data source somewhere, you won't understand it. So what workbooks does, it's to help you understand the data. And there are a lot of workbooks that exists that sort of the product teams has built for you. Examples of this is Cosmos DB Insights, Story Guides, different workbooks within Application Insights. But you can also do your own workbooks. You use workbooks and you get the data for all your application, which might consist of different services, and you sort of pull data from a little bit of everywhere, and then you present it in a user-friendly way to troubleshoot your application a little bit better. And from a workbook, you can reach a lot of different data sources. You can reach logs or metrics. You can reach resource graph data, change analysis. You can have JSON, just your own JSON. You can do HTTP calls. You can talk to ARM. You can see the health. And this sort of means that you can almost build a little bit of your own Azure portal, but for your application. And I also have a lot of customers that sort of send data to Log Analytics from their own custom sources, and then they present business data in the workbook to sort of see what's going on with the application, and, for example, how many sales are we doing, or whatever. And there's a gallery for this that you can check out also. And now I want to demo a serverless application that I built. It's called Is That Rickard? And Rickard, or Rickard, that's my name. And what it does is, when someone walks into my office, a photo is taken of them and uploaded to Azure, or uploaded to a function actually, and saved in a Cosmos DB. It then does face recognition on that image, and then it tells us if it's Rickard or not. So this is a picture when I walk into my office, and is this Rickard? Yes, it is, and it's posted to Teams by a logic app that sort of says, yeah, Rickard has just entered the office. And if Santa Claus goes into my office, Teams will tell me, sort of, alert, someone else than Rickard just entered the office. And as you can see, Santa also loves Azure App Platform, so that's great. So this is the architecture of the application. Someone walks into the office, photo is taken, that is uploaded to a function app. History audits is saved to a Cosmos DB. It then writes to a queue, and another function sort of reads this queue and picks it up, and then sends the image or the information about the image to cognitive services that does face recognition, and then posts the result to Logic Apps. And Logic Apps then has great integration with Teams, so I chose to do it that way. So that seems to work fine, right? But something is wrong. The application isn't working that great, and we're getting some alerts. So let's jump into the portal and have a look. So we go to alerts here, and we can see there, okay, we actually have an error here. And we can see that it's an alert of severity error here. Alerts can have 5 different severities and 3 different states. So let's look in here and we can see that, okay, we have a error here, and the affected resources is application insights, which is my functions are attached to. If we then go here and have a look at availability, we can see that I have a bunch of availability tests that sort of tests my functions and the whole sort of chain of calls. And we can see that here we had everything went great here until like 50 minutes ago, and then everything went wrong here. So that's a shame. So that's not good. So we can also jump to a workbook here and have a look. That's the SLA report. This is a pretty new functionality in Application Insights, which sort of shows me the SLA I had for the last hour. So as you can see here, my overall availability for the last hour was 23%, and that's under target because I have a couple of 9s as target. And so this one I could use to sort of see how my application has been doing for the latest time. But let's jump back and have a look at the application map. And the application map is a great feature. It gives you an overall look on how your application is doing and all the parts of your application. So here we can see that this is my function that my camera calls, and this is the function that that reads from this queue. So this one puts something on the queue, and this one reads it and sends it to logic apps and to cognitive services to do the face recognition. But as we can see here, we have 100% fails when it comes to calls here. So let's take a look at this one. And we can see here that we are getting a 401 HTTP status code here. And that means not authorized. So let's click investigate failures here. And we are seeing here that, okay, we have had a lot of failures here. Boom, boom, boom. And we can see a little bit here that, okay, this is a notification that every time an update of my application is delivered, meaning that the build pipeline delivers a new update of the application, or someone commits something to the functions, this one is also written. So we can see here that we have a release called security updates by clumsy developer. Okay, and it's this build. So this sort of tells us a little bit, okay, something went wrong when we did this deploy. Okay. Let's jump back a little bit to this one, and let's go into Cosmos DB Insights. We can jump to Cosmos DB from here. We can scroll down to monitoring and click Insights. And now we're presented with the metrics for Cosmos DB Insights in a very user-friendly way. And everything sort of seems fine here, but all of a sudden we're not receiving any calls anymore at about 11:30 today. Okay. Since we have a 401, I'm thinking a little bit, okay, did we change some keys or authorization stuff or something like that? Did we maybe rotate our keys in the Cosmos DB? Doesn't seem that we did that. Otherwise, we would have some info here. Is our Cosmos DB available? Yeah, it's available 100%. So now I sort of want to know, okay, I did my deploy, and what changed in Azure when I did my deploy? And then there is a great service called Application Change Analysis that we can have a look at. So what we do here, we want to look at the last hour, and we want to check our resource group called Is That Record? And we can see here that something properties, let's see. Properties, let's see. What happened here? You can see that someone, I was expecting to see some configuration change here actually. Yeah, here we can see that someone actually went in and changed the configuration or connection string for my document DB, meaning my Cosmos DB then. And okay, what was that? Okay, I can see. So okay, someone changed the account key in the deploy for my Cosmos DB. So that's probably why my function can't connect to the Cosmos DB. So I know sort of that's probably the reason for why I got an alert and the availability tests failed. And I can also see here that, okay, the one who did this deploy was actually a clumsy developer, a member of my team. So that sort of showcased application insights, Cosmos DB insights a little bit, change analysis, and Azure alerts. So yeah, what kind of different monitoring services am I then using for these serverless services then? I'm using metrics, of course, that's free and sent automatically. You could set up diagnostic settings or logs, and that would sort of be metrics are, we have had 10 requests the last 5 minutes, for example, but logs would be that the logs would be every request, the log for every request would be sent to logs. So we could do that. For functions, I would use application insights and function app diagnostics, which is sort of an other monitoring feature of app service or function, which is great. It sort of knows a little bit more about your infrastructure. For Cosmos DB insights, for storage queue insights, and for logic apps, if something were to be going wrong there, it also logs to log diagnostics, and you can see the stuff there. So yeah, and some other services that I'm using is of course Azure Security Center to see that my application is configured correctly. I'm using, of course, developer-friendly tooling like Portal and dashboards, as you saw. I could also use Visual Studio to view the application insights data, for example. And as you saw, I'm using Azure Alerts. And I could also send these alerts to an Azure mobile app if I wanted to, a Teams channel, or actually do automated healing if I felt like it, and triggering off some logic app or some other function to sort of mitigate the error. So Cosmos DB insights. As I told you, you saw the workbook sort of showing metrics in a user-friendly way for your Cosmos DB. You can enter it through the Azure Monitor blade if you want to, and there you would get sort of a view at scale of all your Cosmos DBs and how they're doing, sort of an aggregated view of that. Or you could jump into the Cosmos DB resource itself and click Insights, and there you have all the data. And I'm a little bit out of time, as I can see here. So I jump to learnings. So doing monitoring, it's really important to get your whole organization the right mindset. You need to work on the culture. Everybody needs access to the monitoring data. Really important. Everyone needs to care about your application. Everybody needs to sort of see the monitoring data to feel that they're a part of it. Monitor your monitoring costs. That's really important because it can get expensive. And there's actually a way to monitor your log analytics account in Azure Monitor, so you can set alerts and all that for that. Monitor all your environments, as I said. Then you learn how you should monitor your application before prod, and you try it out. You build it, you run it, you monitor it. Yes. You should, if you build an application, you should be the one that's responsible for running it. And if your organization doesn't allow that, work on the mindset or culture of it. View your monitoring dashboards like workbooks and the portal dashboards every morning meeting, sort of your stand-ups or something like that, to get everyone involved. No matter if it's serverless applications or not, it's really important that people understand the monitoring of the application. App map and workbooks are great to get a visualization of your data and also understanding your application, of course. Access model. You need to think about the access model for your data, and you need to think about what you monitor or what you log, so everybody can get access to the monitoring data, so it's not sensitive information. Yeah, so don't forget to check out all of the treasures in Azure Monitor. Your customers will thank you. You will get higher SLAs, fewer incidents, and all that. And it's fun if you do it the right way. Okay, that's it for me. Any questions?
Really great story, and we got some compliments in the chat on that application that you built. That's a fun application. And it's always good to know that Santa is not in your office.
Yeah, exactly.
And that is a real fun one. I'm wondering if you have you had something like that in I want to say in real life, but you know what I mean, in an office situation, so in the field. Have you
mean
seen that you can use Azure Monitor for these kind of applications? Have you seen that you could solve some issues because of that?
You mean just in general, not just in my demo application? You mean? Mm-hmm. Yeah. So I've worked with customers for maybe 5 years to implement Azure Monitor, and I mean, once they start to learn it and understand it, they sort of love it, because you do get great insights, and Azure Monitor really understands Azure and understands how PaaS and serverless resources work, and it's super easy to instrument them also with Azure Monitor, since it's sort of built into the portal. If you're using other monitoring tools, that's a bit, well, it's maybe easy for virtual machines, but when you sort of get up in the stack, they are more and more closed off, and it's harder to sort of get the insights that you want to have. And that's why I always recommend Azure Monitor for my customers if they are in Azure. So
Yeah, and I agree that Monitor is great as a tool, but it can be a bit overwhelming, because it's like everywhere, and then you have the dashboard, and then you have Kusto language. What would you recommend if someone's listening and thinking, well, I want to learn about Azure Monitor, I want to get started? What would you say is a good starting point?
Yeah, so there are I would sort of start with, okay, I have an Azure function and I want to monitor that. I would start with that and sort of go to the function documentation, and there you would see how to use application insights, for example, together with Azure Monitor, and how you would send logs there and use that functionality. So it's really big, but just instrumenting one service and starting from there, it's really easy. I mean, you set up application insights with Azure Functions in like 2 seconds, and it's just 5 clicks, and then you're there, and then you can start using the application map and the performance insights and all that I showed off. So it's really easy. Yeah,
that's a great tip. Great advice. So thank you for this great session, great demo. It was a really fun time to look at it, and thank you.
Great. Thank you.
And now let's call our next speaker, Jan Henrik Damashka. one of my favorite tools in Cosmos in Azure. So he's going to be talking about serverless web applications with GraphQL, Cosmos DB, and Azure Function. So
Right.
I'm very excited for this. Take it away, Jan and Rick.
Yeah, thank you. Okay, so I think you can all see my screen great. Yeah, we are going to talk about serverless applications today, and this talk specifically focuses on serverless web applications with GraphQL, Cosmos DB, Azure Functions, and a lot more Azure services. So mainly focusing on Azure services that are serverless. And just as a little disclaimer, I hope you are not afraid of code. We will see a lot of source code in some slides. We will have some very interesting demos, and as this will gonna be an architecture that is based on a real-world application, it's not going to be extremely simplified. It's simplified enough, but just for you to know, it's not your everyday Azure startup template, to say it like that. So just a few words to me. I'm Jan-Henrik Damaschke. I'm CTO at Visorion and Senior Cloud Architect. I'm a Microsoft Azure MVP, I think since 6 years now. And you can reach out to me at Twitter at my handle that is on this slide. You can, of course, add me at LinkedIn, and you can read my blog posts and the ones that some colleagues of mine and some people from the community write at itinsights.org. I can just recommend to take a look at that. So let's start. So why at all do we talk about serverless? What has been the journey in the past, and why are we talking about serverless, especially for web applications? So the first thing that comes to my mind is, of course, scalability. So with scalability, what that actually means is that you have the choice to scale. So many services scale out automatically for you. They scale out by time or by user count or by requests or something like that. But you can also choose to not scale anymore or choose to scale out indefinitely, basically. So that's what you get from that. And with that comes performance, especially for web applications. Today, like, everything is possible. We are coming from a time where PHP and pure server-side rendering was the standard. It was just normal. After that, we had some like dynamic web applications. Then there was a phase where we had a lot of static pre-rendered web applications, so static site generators, for example, things like Gatsby and so on. And after that, frameworks like React and Vue that are basically the standard today were coming out, and frameworks on top of these like Next.js or Nuxt for Vue. And these provide basically the best from two worlds, and the next iteration now is to combine like the best of server-side rendering and the best of pre-rendered websites, basically. And that is where serverless can really help us, because with the technology that we have today, it's you can do everything. There's, for example, a new version of Nuxt that's a framework based on Vue, where there's an experimental implementation that renders your complete website inside of a browser web worker. So everyone who's a little bit familiar with web technologies knows that server-side rendering inside of your browser is a little bit crazy, but it just works, and that's fantastic. So you can do nearly everything today, and that improves your performance, not only in regards to usability and latency, but also for things like SEO and so on. So, of course, pricing. The price scales with demand, so you have pay-as-you-go pricing for nearly everything. In Azure, more and more services are getting the serverless tier. Just a few months ago, or a few years ago, there were no serverless tier for Cosmos DB, and today there's a serverless tier for Cosmos DB. There's a serverless tier for many other services. Azure Functions, of course, has a serverless tier, the consumption plan, and so on. So you can create nearly all services that you need for your web application architecture in some kind of serverless tier, which basically means that you pay as you go. You pay per request, per second that you use the service, things like that. Then normally you have a smaller maintenance. fee and smaller maintenance time and effort for this, because you are starting to focus on other things. If you start to adapt serverless applications, you have to have some kind of DevOps methodology in place. So you can really grow from this. And if you already have things like DevOps in your organization or some kind of DevOps-based methodology that you use for your daily business and to operate your applications or the applications of your customers, then this helps a lot. Then, of course, CI/CD. Many serverless applications have first-grade integration with CI/CD services. The GitHub integration of static web apps that we will take a small look at if we have time for that in a short minute is a great example for that, because you have things like one-click integration from Azure. So if you're in the Azure Portal and set up your new static web app in Azure, then it directly pulls your available repositories from GitHub and pushes the correct pipelines into your GitHub repo. And that means that you don't have to care about like setting up your pipeline, setting up your pull request processes and so on. That's at least in a base configuration already done for you. And you can deploy and set up your whole CI/CD experience in just a few seconds with static web apps, just as an example. The other thing that I like a lot about serverless is the developer experience. So the separation and decoupling of services helps a lot with debugging and troubleshooting. So you can troubleshoot much more targeted, and you can also do much more focused debugging. And of course you have the choice of language, because if you have different people that come from different backgrounds, with some people that use C# and some people that use JavaScript or TypeScript and things like that. In the classic app development world or application development, you would have to focus on one language only. But if you have decoupled microservices, you can choose either the language that is best for the task or the language that is that your developers are most familiar with. And that is something that is really helping with developer experience, because you don't have to learn something new every day. And the last but not least point is security. And I wrote it last in this list because it's extremely important, but it's something we cannot focus too deeply on today. We can just take a look at some implementation and something you have to consider if you're thinking about security. But basically, DevSecOps, integrating security services into your pipeline is extremely essential. So things like Key Vault, Azure App Service, Managed Identities, there's a lot of stuff inside of Azure. We've already seen the Security Center and all the information that is provided by that. So there's a lot of stuff going on with that. So I already mentioned static web apps. Static web apps is a relatively new service in Azure that integrates with your serverless web applications. That is a great start to host your web applications, and it has a lot of very interesting features. So there's basically a reverse proxy, which means that if you're connecting to a static web app, every request that you make is going through the static web app service first and is then evaluated based on your configuration. That means you don't have to care about routing anymore. So if you want to redirect a specific route in your web application, you can just put that in a config file, and static web apps takes care of that. If you have a route, and that's really interesting, if you have a specific route that is not allowed for a specific group of users, you can just write that in a config file, and static web apps will take care of that. So you have authentication, authorization, and the whole routing thing as a platform service, basically, where you only have to configure a JSON file, and that's it, basically. We will take a look at the config file. I hope we have enough time. I will hurry up a little bit. Then we have an integrated CDN, some caching optimizations. I already talked about the GitHub integration. That is really great. You have free SSL certificates coming with the service. You have a free tier. Everything that we are talking about right now is completely free for everyone. So you can just set up a static web app, and all this, including the SSL certificate for your custom domain, is included. And you have integrated authentication. That means that you inside of the service can just define roles for yourself, for example, like administrator, moderator, whatever, and assign that to specific users coming from different services. So you can invite your colleague with a specific email or with a GitHub handle or something and assign a specific role to him. And if he accepts the invitation, he just has that role and you don't have to care about anything. Not about authentication, authorization, OpenID Connect. That's all out of scope if you don't want to handle any of that. Then you have the pull request reviews, which is a really great feature because when you're creating a pull request, Static Web Apps automatically understands that you've created a pull request. So this is just available for GitHub, by the way, not for Azure DevOps, but I think the majority of people is migrating from Azure DevOps to GitHub anyway. So pull request reviews provides you a preview branch that basically takes the code from your pull request branch and deploys it to a new instance so that you can preview the changes and see if everything is right. Like I said, the free plan is including not only all the hosting features and the platform features that I just talked about, but also an instance of Azure Functions. So you can deploy an additional Azure function that's basically a consumption plan function, but it's abstracted so you don't have direct access to that function. You have to define that in your code and then deploy it. And then you have a web front end on the one side and then the then the Azure function at a specific route, and that's where it gets interesting because the Azure function, the default one, is always mapped to /API on your static web app, which means that you don't have any CORS issues anymore. You don't have to handle CORS at all. You can just query from inside of your web application /API, and you have direct access to your Azure function app. Then there are some premium features, and there's a bandwidth limit that you should know about. And now we get to the interesting part because I've seen that the sessions are only 25 minutes long. So as a demo, I have created a little application that you can open under sessionfeed.app. And this application will enable you to create your own questions for the session. And I may be able to answer that. And you can also comment on questions from other people. So I will just switch over to that so that you know what I'm talking about. So if you go to sessionfeed.app, you will be presented with the login screen. This is everything based on Azure Static Web Apps. I have to log onto my other screen to interact with that, so please excuse me for that. So I will log in with my Microsoft account. And what it will basically do, it will, because I'm already logged in, it will take my Microsoft account. If you're logging in for the first time, you will be asked to consent to provide your data. This is basically just for the service to be able to log you in. This is all the data. This is why I just printed out the raw object here that you see if you log in. So the identity provider and some other stuff. So this is everything that is handed over to the application basically. And the first thing that is interesting that you already see here is that the web application itself connects to /auth/me, and that's the endpoint where the front end, the web application, gets all the user information about the logged in users. I have not configured any authentication at all. Just inside of my static web app, I have told it that this path is authenticated, so it just requests the authentication from you. And this is what happens then. And if you go to talks, yeah, you see I've created another talk because I was confused about the time zones. It was too early, and then I created another one. And this is the current talk. This is why the recording sign is on. And you can go to discuss to ask some questions. It will load up a little bit. We will talk about the architecture that is behind this in a second. So there are no questions right now. So I will just create a question. This is the first question. What is static web apps? And I'm going to ask this question. And what is interesting is that this question has now appeared here. And there's already someone who asked another question. That is great. And if you go to reply here, you see the answers. There are no answers yet. You can add your comment if you want on my screen, because I'm in full screen mode. There's a little bug down here. But you can just add your comment. And we will be looking at this, and I will be looking at this after the session. But now we will talk about the actual architecture that is behind that. And during the presentation, we will also be notified about any potential comments or questions that come up. So this is the application architecture. I already warned you. Oh, there's a new question already. Great. I already warned you that this is not the most the least complex architecture that you can think about, but it's basically the static web app hosting the front end, which is written in Vue, and the API that is written in Azure Functions. It's an Azure function. It's all based on TypeScript. And what I did in TypeScript, because that's also the thing that we did in the customer project where this is based on, is to use GraphQL in there. And we will just take a look at GraphQL in a second and why we've used it there. But GraphQL is basically used as an API gateway here. So you think, okay, you can also use an Azure API gateway, but the Azure API gateway can also be used, of course, for like external things. But the GraphQL API, or in this case Apollo Server, is that's the, I would say, most used GraphQL implementation that is out there. That is used as an API gateway for multiple reasons, because you have you have a microservice-based architecture. So we have a message API and a session API, as you see, and the front end only communicates with GraphQL. And the thing about GraphQL is that because it's behind the static web app, we can use the whole authentication and authorization part, which is sometimes a little bit of pain in GraphQL, and we can use that completely provided by the static web app. And we just use that to handle our user roles, the authentication and all that stuff, and we only have to add some very little things to make it possible to forbid or allow specific users to access specific endpoints. You will see what I mean in a second. And what you also see here is that the front end always connects to the proxy in the middle, so to the static web app, and then the static web app connects to GraphQL, and thereby also checking if you have the permissions. So that is basically the single point of control, the static web app itself. And after that, the GraphQL API gateway will connect to the other microservices that you have. I have just created this app a few days ago. So it just has a session API and a message API that is basically used to query some session information, like the questions that you've seen and the comments. And the message API is used for polling information. So, like I said, we have the Azure static web app, and I'm on the wrong slide actually here. So, okay. So we have the static web app, and the static web app hosts our Vue.js based front end. Then we have the back end, the MongoDB, Mongo API based Cosmos DB, some Azure functions, and Azure PubSub. I will not talk about this anymore because we don't have any time. But Azure Web PubSub is just like SignalR. It's just a WebSocket service to notify about some new things. So why GraphQL? So GraphQL is basically a query language for APIs, which provides us with definitions for specific endpoints and specific resources. And we choose this because everything is based on TypeScript, and with TypeScript, we have the possibility to define our types and share it between the front end, the back end, and all the microservices. So we have a shared library of definitions, basically, that is used for the resources in the front end, as well as in the back end, as well as the GraphQL definition itself, and thereby also the API gateway and controlling what is available and what's not available. Then it also works great in serverless, basically, because Apollo Server, which is the implementation that I talked about of GraphQL, provides some very good serverless packages. So you can run it on AWS Lambda, you can run it in Azure Functions, you can run it on Vercel with serverless functions, you can run it everywhere, basically. And there are some caveats to that, but it basically just works the way you expect it to work, and it's also quite fast if you do some optimizations here and there. So the application that you are currently using, because I see that there are some questions that are coming in, this application, there's no optimization basically. So this is the raw performance of just the cheapest tiers in Azure that you can have. There's no caching, there's no anything. So there's a lot of potential for the UI, responsiveness, and so on. Also, GraphQL has a very rich ecosystem with some tooling around. So we have no subscription support. Is something that you should know in serverless, because you can subscribe to a function, and sometimes authentication and authorization can be difficult, but that is why we use Azure Static Web Apps. And I will switch to the Azure Portal, because in the Azure Portal we can see we have all our resources in a specific resource group. And this is just application insights with all the microservices connected. So the API itself and the front end, the session API and the message API. And we can go to the back to the resource group, and you can see that in this resource group we have just some consumption plans for the Azure functions. We have the Cosmos DB, and we have the Azure functions themselves and the static web app. And the static web app, like I said, has only a few configuration options here. The rest is done in a configuration file. But the only interesting thing that I want to show is that I've also created a specific invitation. So every user that logs in, like you all are logging in, you all get the anonymous and the authenticated role. So that is how you can check if a user is actually logged in or not. And I have created another role assignment for myself, so that's my GitHub handle, and I also have the speaker role. And what that enables me to do is, you probably spotted the new question here, and if I log out and log in with my Microsoft account, you will see that the new question, new talk button here, new talk, is not available. And if I log in with my GitHub account,
we have to break in because we're running out of time.
I've only done 22 minutes. I have my counter running.
Yeah, unfortunately, yeah. But maybe we can at least take one question from the app that you built. It's a very interesting app, by the way. So
we can just go to the takeaway slides if that's okay for you. So that's basically the important part. So
no, we have to wrap up. I'm sorry. I'm really sorry about it. Maybe you can share your Twitter handle real quickly and share it on your Twitter so people can see it there.
Yeah, of course I can. I will also show share the slides as a whole part. So, but like I said, you can just ask more questions in the app, and I have the takeaways on right now, and I will also post the link to the whole presentation right there. And yeah, I think if we're running out of time, that's a little bit bad, but I cannot change it.
Unfortunately, a lot of interesting stuff in your talk.
Right.
Absolutely. Yeah.
Mm-hmm.
Okay.
Thank you very much, Jan-Henrik. And for now, we have some content for you about Cosmos DB. And as many of you know, for a very long time, Cosmos DB only had one way of provisioning throughput. So if you're designing your Cosmos DB strategy, you would have to understand your workload first to know how much you need to pay upfront. And sometimes if you set your throughput too much, then that's a little bit of a waste of money. And if you set it too little, and then your app's performance can suffer. But we all have different use cases, so it's very nice to have choice. And if you're interested in learning about your different choices and different ways of setting your throughput in Cosmos DB, please watch this video.
Azure Cosmos DB helps you get more value for your money by making it easy to manage the components you pay for, database operations, and storage. The cost to perform database operations, including memory, CPU, and IOPS, is normalized and expressed as a request unit. More request units are charged for more demanding activities. For database operations, you can select one of two models, provisioned throughput or serverless consumption. Provisioned throughput is the capacity you allocate for database operations, measured in the number of request units per second and billed hourly. It works best for workloads that always have some traffic and require high-performance SLAs. If the traffic is predictable, you can use standard provisioned throughput to manually set and adjust capacity as needed. If the traffic is unpredictable, you can use auto-scale provisioned throughput to instantaneously and automatically adjust capacity between 10 and 100% of your set limit. Autoscale becomes more cost-effective than standard when traffic is unpredictable and not close to maximum capacity most of the time. Provision throughput may not suit workloads with only occasional database operations and lower performance requirements. These applications can benefit from the serverless model. While it has a higher unit cost, it's consumption-based and only charges for the request units used per database operation. With consumed storage, fees are charged for the total gigabytes used per month for both transactional and analytical storage. You also pay for storage I/O and analytical storage. Get the most value from your workloads by understanding the components you're built for in Azure Cosmos DB.
Okay,
There you
cool.
go.
Let's quickly move on to the next speaker so we can focus all our time on the talks. Jonah, welcome.
Hi, I'm Marilag and
Hi.
Barbara. Nice to meet you and great to be here. Thank you for having me.
It's
Hi,
so great
Jonah.
to have you as
Hi.
a speaker here. Awesome.
Yes.
You're
it's
joining
been
us
here.
from Sweden also, right?
Yes, I'm in Sweden.
Awesome.
Yes.
Well, no further ado, just take it away. The floor is yours.
Yes, sure. All right. Hi, everyone. Today I will be sharing about the different patterns of Azure durable functions, and I hope to do this quickly within the next 25 minutes, so we can also have some questions. So before I start, I want to introduce myself. I'm Jonah. I'm a software engineer. I code full stack .NET development. I work at Forefront Consulting. I'm an Azure developer, Microsoft MVP, and a technical trainer, and the founder and co-organizer of Azure User Group Sweden, a local user group here. And today I want to talk about a bit about durable functions, Azure functions, the different patterns. And I wanted to show a code demo, but I don't think we will have time for that. But I will show you some use case example later at the end if our time permits, and then some recommended learning resources. So I want to start my talk by sharing with you about this problem, the airport queue problem. So since COVID, as we all know, we've been working from home for the past year. And I know that we miss traveling, but definitely when the world opens up again, we're gonna be experiencing airport queues. And definitely there will be long lines, and when we ended up in this queue, sometimes we wish that we could do something else, like grab a coffee, relax at the airport, and just use the self-service airport, machines. But then sometimes we cannot control that, and it can be challenging. And my point here is also for that airport queue is that about programming. In programming, we experience concurrency problems. And when I was studying Java development years ago, I encountered this problem. It's called the diner philosopher's problem, in which the scenario is that there are 5 philosophers and 5 forks. And the scenario is this: each philosopher needs both forks, left and right, in order to eat. Otherwise, they can't. Each of them can't. So the problem here is related also to programming. For example, in this case, for the dining problem, there will be an issue with the deadlock, which means that if one of the philosopher picks both left and right, then no one can eat. And if no one can eat, then that means they can die of starvation. So this is the reason why I want to point out as well that in programming, we experience a problem of concurrency, racing conditions, and deadlock. And I believe that the solution for this would be serverless, especially right now I'm talking about Azure functions or durable functions. And I, as a developer, I love serverless because I can solve complex problems, I can build modern apps, and it makes me productive as a developer. So I love serverless. So I want to give you a brief overview what Azure Functions is. So it is the serverless compute in Azure. You can have it on demand, and you can pay as you go, pay only for what you use. And it is event-driven, function as a service. So it's perfect for event-driven apps or architecture. And as a developer, you write less code. And that means you also get developer productivity, which means for us developer teams, we don't need to worry about maintaining the servers or like maintaining or upgrading the infrastructures behind it, because the cloud provider, Azure, takes care of that for us. And of course, just like the previous session, we had a lot of sessions about integration with logic apps, Azure SQL, and Cosmos DB. Azure Functions integrate very well with Azure APIs and services, as well as external APIs. So basically, Azure Functions is composed of the logic that we have in our function app, the code, and also the events, which are the triggers that we use, HTTP or blob trigger, and also the data, for example, the bindings, the input and output binding. So that is Azure Functions. So what are durable functions then? So durable functions are extension of Azure Functions. So it allows us to write stateful workflows in serverless environments. I know that logic apps can allow us to do that as well, but in durable functions, we do it more in the code. So it's more code driven in the logic. And it's also a compute service. What's good about durable functions is that it manages and checkpoints and even restart the state for us, and we don't need to do that. And the technology behind durable functions is the durable task framework, which you can check actually on GitHub through that link. So, and also it supports different languages like C#, JavaScript, Python, F#, and PowerShell. And now let's go to the different types of durable functions. So there are different types. There are 4, but the top 3 are like the client functions, the orchestrator functions, and activity functions, and the last is entity functions. So client functions are like the starter functions. They kickstart the orchestrator. It is the starting point of the orchestrator. It can be an HTTP trigger, a blob trigger, service bus trigger. And then we also have the orchestrator functions. In orchestrator functions, that's where you describe your actions, your workflow, and how you want your tasks or functions to be executed. And we also have activity functions. So activity functions are like the normal Azure functions, actually. They contain the basic unit of the workflow, like the task that needs to be done. And activity functions can only be triggered from the orchestrator function or through the workflow. And then next we have entity functions. And entity function types are used to define operation for updating small pieces of state, like it's also called durable entities. And the difference between the other types and entity functions is that you need to use entity trigger. And it's supported from durable functions version 2 and above. And I think it supports .NET and JavaScript, and I think Python recently. And what differs Azure functions from durable functions? So Azure functions are stateless and durable functions are stateful. And This is a big difference, because sometimes I get a question, what's the difference between them if they're like extensions or about the same. So these are the big difference between the two of them, but they're there to help us in providing solutions in our different use case scenarios in organizations. And one of the most important type in durable functions are the orchestrator functions. So the orchestrator, it needs to be designed or coded properly, because it is deterministic. And it is important to be determined in your design in the workflow, because the functions, the orchestrator function, will be replayed. And if you want to learn more about deterministic API, you can check out the link on this presentation to learn more about the details of how it works technically. And here is an example of deterministic versus non-deterministic. So here on the left, we have the durable functions with an orchestrator, a determined orchestrator, which has a workflow for all its activity functions. And then on the right, we have isolated group of Azure functions that has no orchestrator. And the difference here is that, for example, if the VMs of one of the functions here on the right, without the orchestrator, gets restarted, then there's a possibility there's a possibility that you will encounter some problems, because it can be a state, it loses its state when the VM is restarted in Azure. And we also have three things to think about when we're designing our orchestrator. And there's a code constraint documented in MS Docs, the do's and don'ts. For example, when you design your orchestrator, it is recommended not to generate not undeterministic list of things. So, for example, grid, they are random, and like blocking APIs, infinite loops, and current date time. Of course, the time ticks all the time, so it's not really like constant. So what is recommended instead is the do's. For example, for grids, you use a new grid method. For configuration, you pass it in your activity functions. And if you really need to use like threads, you can make use of the functions available through the context. And if you really need to do a loop within the orchestrator, then you can use the create as new method. And there's also a specific function for the datetime. And I want to introduce you to the first pattern, which is called the function pattern. So function patterns execute a sequence of functions in a particular order, like a chain. So like this. So we have function 1 that pass in a parameter or data into function 2, and a function 2 pass in that result or output to function 3, and a function 3 pass in that output to function 4. So the output of function 1, for example, is required as an acquired input to function 2, and so on. So in action, it looks like this. So for example, if you have HTTP trigger, a blob trigger, the orchestrator gets started. So when the orchestrator gets started, the activity 1 is scheduled. The orchestrator sleeps, activity 1 is done, orchestrator wakes up, activity 2 is scheduled, it sleeps again, and then activity 2 is done. The first orchestration is completed. And that continues as long as the orchestration is long running and it's triggered. So the good thing about this is that when the orchestrator sleeps, you don't really get charged for those activities or functions that are not running. So that is very good when it comes to consumption or cost perspective. And here is an example of a hello sequence in the documentation for function chaining, where you have like a hello sequence to say hello to the different cities like Tokyo, Seattle, and London, and return the rest of the output. And then the next pattern, the second pattern, is fan out and fan in. So this is how it looks. So in fan out and fan in pattern, you execute multiple functions in parallel, wait for all the functions to finish, and then aggregate the result as one when all of those parallel tasks are done. And this is how it looks in code, for example. So here we have an example that we can back up site content. And we have files that we need to back up and loop through the tasks for that backup. And it uses the method task when it does its fan in, when all of those tasks are done. And then it returns the result. And the third pattern is async HTTPI pattern, which very common pattern or useful when you want to solve problems in stateful long-running operations, especially with external clients. So here is an example. So here, I hope the screen is okay. It should be white, but anyway, I have a function here that's called check if website is available. It's in .NET since I'm a .NET developer, and what I have here is that I have a try catch block with an object called durable HTTP response, and in here marked in blue, I use an await method to call an HTTP async method, passed in the method that I need, for example, get my URL, and I have an if condition that check if my website has the status code or code that are good, then I get the content of my HTTP response, which is a durable one, or I throw in an error as log. And the next pattern is monitor pattern. So monitor pattern is the opposite of HTTP async API pattern, because this one is different. It is useful for recurring process that can be flexible in a workflow. For example, you can use timers to monitor certain workflow. For example, this one, monitor pattern. You have a function here called monitor job status, in which you have an expiry time for your monitoring, and a while loop that keeps checking if the status is completed. And it's going to call the activity called send alert, passed in this machine ID. And then the orchestrator keeps on will sleep until the next check or expiry time. And then the next pattern, the fifth pattern, is the human interaction pattern. So sometimes we need to solve problems that requires human interaction. So for example, this one, the approval process workflow. So a function needs to send requests for approval to a human being or a person. But sometimes a person, for example, a manager that needs to approve something is not there. Maybe he or she is on the vacation and it can't answer right away. So this is the reason why you can also add a timer to automate the process. So here, for example, we passed in a request for approval, and if the person responds, then process the approval. Otherwise, after a certain time, you can also escalate it or do something else. So this is how it looks in code example. So you have a method here. You have a timer, durable timer, and you also have a method called wait for external event from the context to wait for the response from a human being. And the last but not the least, one of the patterns is the aggregator pattern. This is commonly used for stateful entities, or where you aggregate the event data over a period of time as a single entity. And this event data can come from different resources, and they can come anytime. And the aggregator aggregates or handles them as they come. And this can be tricky to fix in a normal function, because in a normal scenario, you would need to send it in a certain kind of queue, and then you need to keep checking on the queue as well when the trigger comes in or the message comes in the queue. So with aggregator pattern, you can solve a lot of problems that could make use of this one. So this is how it looks in the code example, code snippet. So you have the iDurable entity context, and in the context you can call get input with the value of integer, set state, and then here you can on the right side you can also signal. You can also use signal entity async and pass in your entity ID in here, the method as well, and the data. And there are more information about durable entities on this link, so you can dig deeper into this and how it can solve your scenarios. And then it is also possible to add sub-orchestration within an orchestration in durable functions. Right now, I believe it's supported only in .NET, JavaScript, and Python. So this is a really good one if you have more complex use case scenario. And this is how it looks in code. A simple example, you use the context and then you call the method named call sub-orchestrator async method. And then you also use the method when all from the task to get the results. So for developer perspective, when you want to develop functions, it's recommended to use this tools. So we have, of course, our favorite tool. You can use Azure Portal, the CLI, Azure CLI, Visual Studio, and Postman, Storage Explorer, and the supported languages. And I wanted to show the code, but I think our time is limited. So I want to show you how my flow looked like in my sample app. So I have here a simple function chaining example. It's like a notifier for when I upload a message into a blob, it notifies me through SMS or call. And it integrates with Azure Service Bus as well as Twilio API and SendGrid. So here's the flow looks like. So I have an Azure Blob trigger, which is my client function, the starter function. And then it kickstarts my orchestrator, where I have my workflow, which is the function chaining. And then I passed in my blob image data into my first function, which creates and sends a message to the service bus as a queue. And then once it's done, it's going to send an SMS call to me as the administrator of that Azure storage with the help of Twilio API integration. And then when I'm done with sending SMS and call, I will also send an email notification that an image blob was sent with the link to the image that can be accessed on the browser. And that uses SendGrid. And the expected results would be like this. So I received an SMS on both my iPhone and my watch. And then I receive a call. And then I also received an email. So if you want to check the simple example, I have it on my GitHub through this link, since I can't do live demo and because of time. And then next is I want to share with you this use case that I'm proud to be part of and to contribute. It's the serverless, the power of serverless for Azure's cloud security. It's called Cloud Katana by Roberto Rodriguez. So I believe one of our hosts, Barbara, is also helping in this project. And what it does is that it uses Azure functions, specifically durable functions, to simulate attack and defense in the Azure environment. And it's really a great project right now because security is something that we missed. We take for granted sometimes when we're developing. And I, as a developer, believes that cloud security is important. And it's good that it's also open source, open to everybody. So if you want to contribute, you can also check out the links in that. And as for learning resources, we have, of course, Azure Functions, Microsoft Learn. We have Azure Functions University by one of our speakers as well, Mark Ducker, and also the Durable Function extension. And I want to thank you, everyone, for listening. And if you need more info, feel free to connect on LinkedIn, on my website, or Twitter. Thank you.
Awesome. Great story on Azure Functions. Yeah, and that's true. I was also part of that project. So yeah, I'm a bit biased.
Yes.
I really love Azure Functions, what we did over there.
Same here. Yeah.
Yeah, I know that you did great job, especially with the PowerShell, and now I think it's planned to be translated in different languages.
Yeah, and actually for PowerShell, the durable functions are relatively new, so it's great that he made use of it that way.
Yes.
Okay, well, most of the questions were aligned like, where can we find this presentation? Because really people love the presentation and all the information on there, and it should be part of the recording later on. But you also gave all your contact info, and I'm sure people can approach you.
Yes, yeah. I can share the speaker deck file for this presentation. And the audience can feel free to connect with me if they have follow-up questions after this, since we have limited time.
Yeah, it looked really great. It was really informative. So awesome session. Thank you very much for that.
You're welcome. Yes, I hope I put my time okay.
Yes, absolutely. Don't worry.
Yeah, not like racing conditions. I hope not. Yes.
Okay. Well, talking about Azure Functions, we want to show a little bit about that, because it used to be that you wanted to build an application, then you have to deploy it to a virtual machine. You need to provision a virtual machine, install underlying frameworks, libraries, deploy it, and then you have to manage and scale that virtual machine. Well, Azure Functions made that drastically simpler, and now you can quickly and easily provision a new Azure Functions instance. You drop your code in there, connect it to all different Azure services, and scale it up and down automatically. Take a look at this video that explains how easy it is to build and deploy serverless applications using Azure Functions.
Up until now, the problem with building applications has been that before you could even start, you had to choose a framework, learn how to deploy that framework onto servers, then manage and maintain those servers over time. Not exactly easy, quick, or efficient. Thankfully now there's Azure Functions, the easy way to build the applications you need using simple serverless functions that scale automatically to meet demand. No worrying about infrastructure or provisioning servers. Whether you're new to development or a seasoned pro, within a few minutes, Azure Functions helps you create applications that accept HTTP requests for a website, processes product orders via queue messages, react to data flowing from devices like an IoT hub, or just run simple scheduled tasks. And since Azure Functions scales automatically, all you need to do is write your function logic. Azure Functions handles the rest. What's more, you only pay for what you use. With Azure Functions, you'll write less code, manage less infrastructure, and have a lot less upfront costs. See for yourself at functions.azure.com and try it, free. You'll see that making applications has never been easier with Azure Functions.
All right. Well, more power to Azure Functions.
Yeah.
We are nearing the end of the first ever Azure Serverless Conf, and I'm sure our audience are still alive out there. And if you're watching the streaming, I hope you got a lot from almost 20 hours. So this is the last leg, and I'm very excited to introduce our final speakers. Let's have them on stage: Luis Beltran, Jesus Gil, and Humberto Jaimes. I hope I pronounce all of your names correctly. And you're all streaming from Mexico at the moment. Wow, I would love to go. I would really love to go. And yeah, how are you all doing?
We are quite happy to be here. Thank you very much for the presentation introduction.
Yeah, thank you very much. And we're looking forward to your talk. And this is Building Serverless Automation Solutions, a use case scenario. Stage is yours.
Thank you very much.
Thank you.
Thank you.
All right. So welcome everyone to today's presentation. Thank you for attending the Azure Serverless Conf. My colleagues and I are really delighted to be here and talk about a use case scenario that involves serverless automation technologies, namely Logic Apps and Azure Functions. And there are also interactions with other cloud services, including Azure Cloud Storage, Azure SQL Server, and even Microsoft Teams and Power BI. We will talk about this in the next minutes. And also, well, please prepare your questions, and hopefully there will be time for doing our best to answer them. And also special greetings to our colleagues from Mexico or from America who are joining this session. So allow me to quickly introduce my colleagues, my friends. As it was mentioned, we are from Mexico, although in my case, I am currently based in Czech Republic. So Jesus Gil was an 11-year Microsoft MVP in data platform. Although he's currently now working for Microsoft as a customer engineer data and AI. He's an expert in SQL Server and other Power BI, data analytics, and technologies related. He has also written several books and documentation that is included in official website from Microsoft. Humberto is a 5-year Microsoft MVP in developer technologies. He especially works with Xamarin mobile applications. Also, he is certified in Azure, and he is a really good friend. And finally, my name is Luis. I am also a Microsoft MVP in AI and developer technologies for 5 years. I'm also working with mobile applications with Xamarin, cloud solutions with Azure, and also artificial intelligence. Welcome, friends. Could you say a quick hi to all our attendees?
Hi, everybody.
Thank you, Luis. Hi, everybody.
Thank you.
All right, perfect. So they will talk to you in the next minutes. So here, let's quickly go through the agenda. This is the topics that we will be discussing. So first of all, my colleague Humberto will talk about the challenges, about the problem that we are trying to solve by using some serverless technologies and also automation processes. Then, of course, we will propose a solution. We will think, okay, there are some ideas that we would like to cover and how technology can be involved in order to solve this. He will present also the architecture of the solution, what specific technologies and how everything is interacting. After that, Jesus will mention the data definition. Okay, we will use a database, what information we need to collect, and also how we are going to present it in a Power BI feedback dashboard. And finally, I will present the demo. We will run the application, and my colleagues will help me with some also comments. All right, so now Humberto will talk about the challenges. Please, Humberto.
Nope, I'm going to present this challenge.
Okay. Sorry, Jesus, please.
Don't worry. Thank you very much, Godfather, for this great introduction to our session. In a world full of challenge, where we have experienced a global pandemic, where the use of communication tools and the teamwork have taken on an unparalleled relevance. We have designed this solution for you. Let's talk about the challenge. First, who is the target audience for these solutions? Mainly students, then for those who organize events for these communities, and later we have endless profiles that our solution can benefit from. What is important to them? Mainly because they want to observe how their career develops. In some countries, in Mexico or in other parts in Latam, it's also required to have evidence that they attended sessions, workshops, events, and etc. Since that makes it a differentiator, for example, when wanting to look for a job or a new job, and then the recruiter can see evidence, okay, that they attending the events, the sessions, etc. So the challenge is to have an attendance diploma or another certification, right? But the solution that exists now is all free. And unfortunately, the most common is that the first diploma are free, but in order to deliver diplomas to all attendees, we needed to buy the full solution. Or, in other case, we needed invest money to create our development. On the side of the event organizers, they need to have the feedback of the attendees to be able to make better events, qualify the speakers, or also to know what topics that the attendees want in the following events. In our experience, we have seen that Microsoft MVPs, MLS, using different tools to can get this goal. But the technology that user is not integrated in a full solution. So we trying to pop together is trying to put a puzzle every time that we run an event. The final need is have to the information available to can use in any time. Okay, so could you move the next slide, please? How do we structure our solution? Okay, we try to do an easily and possible easy solution and divide it into 4 main process. Okay, the first process, we create a serverless solution that process the webinars that run during the day. This is process that run daily and the end on the day and save the information in an Azure SQL database. The second process, we define a set of rules for attendees to earn their diplomas at the end of the event. For example, a rule we defined is that the attendees has been more than 50% of the time of the sessions. This percentage you can change according to your own policy. Okay, the process 3 is always important to have a report where we can view all the information that we have previously saved. And believe it, it's very necessary when you are organize the events. Okay. The process 4, okay, sorry, the 3 is retrieve the feedback, okay, and save this retrieve for later analysis. And the 4, as I say, is the report. Okay, bye. Stop the theory and let's move to Humberto Jaimes, who is going to explain the architecture of our solution. Go ahead, Humberto, we'll listen to you.
Thank you, Jesus. Thank you, Luis. Well, now we are going to talk about the architecture of our solution. The flow is actually very simple. We have an event-based solution where Azure Storage will trigger all the functions that we handle, the information, the attendees data, and everything required to make the solution simple. First, we are going to generate a Teams webinar. This is an option that requires all attendees to register their mails, and also then give us some metrics of the behavior of the session. So we have all the information to apply the set of rules that Jesus talked a few moments ago. It is much simpler than live events, but it gives us more control than a normal Microsoft Teams meeting. That's why we are using Microsoft Teams webinars. In our flow, we have some Azure functions. One runs every 24 hours and analyzes which webinars have already finished according to the dates that we configure in the database. And using the Microsoft Graph API, we can obtain the attendance report, where we are mainly interested in mail addresses and the time the attendance was present in our live sessions. This data is stored in a SQL database, and we write some messages in a webinar queue. The webinar queue triggers the second function, and this function receives the ID of the webinar that was processed before, so we can check the attendance of every attendee, and if they stay at least 51% of the session time, the attendee meets the rule that we need to generate their diplomas. So in a different functions, we can generate the image of the diploma, and the image is uploaded to a blob client. Every blob has the attendee IDs in its metadata, and then the last functions, before we stay to apply some login acts, generate the share access signature key, so we can share the blob with the attendees. Then is where the logic apps appear. We use logic apps because they are easy to integrate with Microsoft services like Outlook to send the mails. And the first logic apps takes the data from the database to send all the emails, including the URI of the Microsoft forms for receive feedback and the URI of the diploma. And every time an attendee fills out the feedback form, another logic app is activated to process and store the responses in the database. And later we can generate some reports. Now, Jesus will tell you about the database and how we are creating this data store for our solution. Please,
Thank
Jesus.
you, Humberto. As you saw previously with Humberto, our database is running in Azure SQL. It's a SQL database serverless. We have 4 tables, being the main one, the table called webinar. Okay, we have tables to save the necessary information to be able to follow out with the attendees, generate their diplomas, and save the feedback they gave us after attending any one of the events. All tables have a relationship via the webinar ID field. These tables will be important to later to be able to generate the report in Power BI, which come in the next slide. And Humberto, can you explain quickly the report we call post-conference feedback dashboard? Thanks, Humberto.
Okay.
Could you move the slide, Luis?
Please, Luis. Thank you, Luis. Thank you, Jesus. Okay, before we take a look of the technical stuff and the code, we have this report. For this proof of concept, the report is very simple. The idea is to create a better report in the future with more information. But as you can see, this report quickly shows us all the webinars and their attendees, the number of the attendees for every webinar. But I think the most interesting part of this is that it allows us to see a cloud of words with the most relevant topics of the session. So the people can share us their comments about the sessions. Normally, our events are made up of more than 50 sessions. So have these kind of reports help us a lot to see what is happening in our communities. And now Luis is going to show you the code and the Azure services more in detail.
All right.
Go ahead, Luis. Go ahead.
Yes, thank you. All right. So we are going to show the solution. You will see some code, but I am taking a few seconds so you can very quickly take a screenshot or picture of this so you can later check the code on your own. All right. So allow me to here we have the elements, the resources on our serverless automation resource group. So as you can see, there is a storage account, there is a SQL Server database, there are the logic apps that Humberto mentioned, and well, other elements required by Azure functions such as App Service Plan and some connections to our elements. You can see here the database in second. Yeah. So here we have our tables. Right now we have 2 webinars and no attendees. Everything was, let's say, removed, so it will work in a few minutes when I show or run this demo, right? So okay, well, yeah, there are 2, but don't mind them. So you will see that these tables will be populated as we run the demo. All right. So here we have our Azure Functions resource, and now I will go to the code that you can also download from the QR code. So in this solution, in this workspace, we have several functions. We start with the webinar attendees processor function, which you can see it's a timer trigger function. Every time at 9 a.m. it runs, but for this demo, I will run it locally on a startup, but it already have the connection to the remote services. All right. So in this code, basically, it looks for webinars which have not been processed. There is a field, webinar status report. In this case, the 2 webinars that you saw are in false state. So after that, we will go through every webinar, and we are going to connect to the Teams graph client. Actually, well, we could have used that, but we are sending a request, let's say manually, by using HTTP client. But of course, we need a token. We have a method to get a token. Here, yes, here. In order for you to access or to obtain information from Office 365 services, you need to set up an application. You need to register an application on Azure Active Directory. In this case, you can see we already have this. And also, there are some API permissions that you need to set up. In this case, you can see calendar read. This is to get all the events that have been scheduled or that are in our calendar. Then online meetings read all allows us to extract live webinars that we have set up and also obtain details from it, such as attendees, the report of attendees that, of course, were in our sessions. There are also important elements. Here. So after we collect this data, we have we get the online meeting, and then we can get the attendance record of every webinar. One important thing is that we can obtain, for example, how much time a person was in our webinar. You can see duration in seconds and also the attendance interval. Yeah, this is quite nice. There is also a property, total attendance in seconds, which will allow us to later evaluate, was this person at least half of the session? If so, let's generate a diploma. All right, so we go back to our main function, and well, we will insert this information in our database. We have a repository. Humberto said that project or helper project for that. And after that, we are going to send to the webinar queue. You can see that this is an output for this function. Here we have the queue webinars. All right. So let's run it. As I said, this is a timer trigger, but it is set to run on a start, right? So you will see the information here, and it will search for unprocessed webinars. After that, it will go through each of them, and it will collect the attendees. As it is running in our storage, you will see, okay, well, we have the diplomas. I will go to that a bit later. But here we have our queues. Okay, queue webinars is here. You will see, okay, webinar 1, webinar 6, the IDs. Okay, maybe they were already processed. So I will go to the other one, which is the queue emails. In this case, the attendees that are, let's say, that were evaluated and were for most of the time will be here. These are the IDs of the attendees, right? And this was just inserted, all right? So in our database, if I run this line again, now you will see that there are several members there already. They were inserted just right now. Every attendee also gets a diploma, and okay, you will see here the blobs. Okay, there, and there are the logic apps that we mentioned. When a new message arrives to the emails queue that you saw, we will build an automation that gets the information from the database, because in the queue it's only the ID of the attendee. So we will prepare the link and also some links, and we will send the email. As you can see in the design, we are collecting, okay, the email, the name of the webinar, the links, right? And actually, you will see in few seconds that I will get the emails, because this queue, this logic apps is processed every 5 minutes. All right. So, well, probably we will not be able to see it, or I can run it on my own. But we will receive the emails at some point. I know we are running almost on time. So allow me to show you. Also, when a new response is submitted, we will insert this information on the on the database, so we can send this information to Power BI. So just very quickly, I will insert some feedback here. I already prepared it, so I submit it. This is our form, and if I go back, I will see that this trigger, insert feedback, just ran. Okay, we are really close to finish. Okay, yes, it is succeeded, 152. And actually, you can also see the emails that just arrived. We are really close to finish. So just a second, because we have a lot of yes, but these emails, I just got them, and you see the information. Okay, feedback and diploma available. Thank you for attending. If I click, I will go to the form. If I click here, I will download the certificate. All right. So yeah, we got a picture. This is obtained from the blob, and if this blob container is private, but there is a SAS token, so only this person, only the person who got this email can see it, can access it. All right. And well, just finally, Jesus will very quickly show the Power BI dashboard with the responses from the feedback form.
Thank you, Luis. Could you share my screen? Could you switch? Okay, thank you so much. Okay, this report is very easy to understand. Here, the most important is first have the information that I say we have for these tables, attend, speaker, webinar, webinar feedback ID. Okay, and this information is very important to can show this visualization. Okay. Also, we have this visualization is an external. This visualization is named Tat Cloud. Okay. Why we need to use these visualizations? Because it's very important try to get the most popular words that say in the comments for the feedback and the next topics. Okay. And we say we have this data source, and the data source, as you say, is for an Azure SQL database. Okay, this report will be available in the GitHub report. Okay, so you can download when we are available in the next hours. Okay, so it's very easy. We have 5 visualizations, and all in which you can say we have the number of webinars that you run, a number of attendees per webinar, average rating, popular feedback, and request next topics. Remember, the most important here is have the information that we can show all the info that you needed. Okay, return the information to Luis and Humberto to close this wonderful session to our attendance. Thank you so much. My name is Jesus Gil, Dr. Rudo SQL, and gracias totales. Thank you so much.
Thank you.
Gracias. Thank you. Excellent, excellent way of closing Azure Serverless Conf. Now we get to see all of the exciting serverless offerings on Azure with your solution. I love seeing the whole solution architecture. You've been working on a lot of different platforms here. So we don't have any questions from the audience, but actually I do just have one. So do you have any advice for how to gracefully handling errors between all this pipeline? Because you're connecting with different APIs and doing all these things. How are you managing all the errors?
Yeah, there are some log analytics that we can check in order to detect any issue. Also, in Logic Apps, for example, you can check what if there was a problem, what was it, so we can very quickly fix it. And yeah, one of the advantages is that we can work, let's say, in local environment before going to production before pushing it to the cloud. So there are several, let's say, ways to manage the errors.
Well, that's great. So all of the resources that you use, you can run locally, correct?
Mm-hmm. Exactly. Yes, we can run our tests, and then we will be ready to go.
Makes it so much easier. Barbara, do you have any other questions for the team here?
No, this was really a clear session. A lot coming, a lot of information. I like that QR code. I hope everyone got a screenshot of that.
Well, I took a screenshot as well, so I'd love to see your code. But thank you very much for joining us today. It's been really great. And now we've come to the end of our stream here, Barbara. Great sessions, yeah.
Yeah, some great content here. Really, it's a large platform, the Azure Serverless. You sometimes think like, oh yeah, it's functions and that's it. But there's so much going on with the Logic apps and the Cosmos databases and then monitoring everything. And SQL, of course, yeah.
And the best way is really to understand your use case very well and be able to pick the right technology or the right resources for the job. And I think the sessions that we had here will really help you make those right decisions.
Yeah.
So if you're watching or if you miss some of our live stream, you can go ahead and check the website aka.ms Azure Serverless Conf, and also check out the other streams.
Yeah, you can find all the streams that were already recorded, and you can find all the on-demand sessions that are on there.
Thank you very much, everyone. I enjoyed it, Barbara. I hope this is not the last time we're hosting an event.